Okay, so the next video that we're gonna look at is the next content will be law of cosines. Before we get into law of cosines, I want to lay out a couple of quick little ground rules that I've kind of been neglecting because I haven't needed them yet. The first one is going back to law of sines. What we saw in law of sines that was that we could use that to solve problems involving angle, angle, side given, angle, side, angle, or the bad one, which gives us the ambiguous case, was angle, side, side. And so then the other ones will be covered in this video in law of cosines. We're going to do side, angle, side. We're also going to do side, side, side. So that's what we're going to cover in this video. The other thing I wanted to mention about triangles is if you are given, let me just go ahead and draw my generic triangle again. This is just kind of a reminder from geometry or maybe earlier, I'm not sure when this is covered. The smallest, so we talk about sides corresponding here. A corresponds with A. Angle A corresponds with side A. That's why those letters match. I've talked about that in a previous video. But what I want to mention here is that the smallest angle will correspond with the smallest side. And the same with the largest, so largest angle will correspond, I'll just use that for correspond with the largest side, and the middle as well. So this is a really good way to check your answers. If you end up with, if you order the sides from smallest to largest and they don't match up with their corresponding angles from smallest to largest, that means you probably did something wrong. So this is a good way to double check your work. And we're going to use this concept in the law of cosines video today. All right, so let's go back to law of cosines. And once again, I'll draw that triangle. It really doesn't matter how I label this, like I've said before. You could put A, B, C wherever you want. You could use X, Y, Z. You could use any letters you like. So the law of cosines is tells us that if I want a side, let's say C, C squared equals A squared plus B squared. So the first part is kind of like the Pythagorean theorem. However, this is not a right triangle, so we technically have to adjust this. So it's A squared plus B squared, but then we have to subtract kind of a messy expression. It's 2 times A times B. And then we multiply by the cosine of the angle C. Notice that the side over here corresponds to the angle over there. And then A and B, it actually doesn't really matter what order you do because it's A and A plus B and then A times B. So you could switch that up. But that's kind of how I remember it. The lowercase c goes on the left, and then the angle corresponding to that goes on the right. Since the letters don't matter, we could also write this as b squared equals a squared plus c squared minus 2ac times cosine of the angle b. Or we could even say a squared equals b squared plus c squared minus 2 times b times c times cosine of the angle A. So all of these are equivalent. You really don't have to write all of them down. Just know where the numbers go based on your labeling. All of these are used when you're given a side and the angle in between the side. So for example, we would be given B and A, and then the angle in between would be capital C. So this would be side, angle, side. For side, 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 we actually usually rewrite this, the law, in its alternate version. And so essentially what we're going to do here, this is for side, side, side. We're going to solve for the angle C instead of the side C. So we would write cosine of an angle equals a squared plus b squared minus c squared. I'm just subtracting that c squared from both sides and then adding the cosine term, divide both sides by 2 times 8 times b. And so then you would do this and take the cosine inverse. You could also write the alternate versions using cosine of b, cosine of a, but I'll leave that for you to do if you want. So these are sort of the two main formulas we'll be using in this video. All right. So let's go ahead and find all the missing parts. Meaning sides and angles, so all missing parts. We'll just do two examples. So the first one is going to be, let's call it A is 37 degrees. Side B will be 11, let's do centimeters, and side C will be 8 centimeters. Okay. All right. So notice that we're given side, angle, side. I have a side, and then the angle. So this is SAS. So that means that I'm going to use the formula C squared, CB, and then this is side A. So I'm going to use the first version of the law of cosines, except I'm going to do it from the perspective of A because I need this missing angle. I can't use law of sines because I don't have any corresponding angles and sides, and I can't use the sum to find the angles because I don't have two angles in order to find the third to get the sum to be 180. So we're going to go ahead and solve for A. A squared equals b squared plus c squared minus 2 times b times c, and then we're going to multiply by the cosine of 37 degrees. So if you do all this, and then you're going to square root both sides, you can go ahead and double check this on the calculator, you should get about 6.67 centimeters. And that's A. Now, it doesn't matter too much what we do next because we could actually use law of sines at this point. So notice how I have these two corresponding angle and side here. So we could use law of sines if we wanted, or we could continue using law of cosines. If you do use law of sines, it's really important to remember to actually use a special angle because you want to avoid the ambiguous case. So if you're going to use law of sines, which I will, so if using law of sines, don't use the largest angle right now. The reason for this is because you could get some ambiguity. You could, let's say you get 80 degrees, then the other option would be the supplement, which would be 100. But if you don't use the largest angle, there's no ambiguity. It's only the largest angle that could potentially be obtuse and acute. So make sure not to use the largest angle in this case. And usually what will happen is you'll use law of cosines first, and then you will need to use law of sines in order to solve. So this is going to come up a lot. Maybe put that somewhere in your notes. Or to avoid it, you could just use the law of cosines, which we'll see in a later example. So let's go ahead and use the law of sines now. I'm going to solve for not the largest angle. The largest angle would be B in this case because B corresponds to the largest side. Because side B is the largest side. So that means I'm actually going to solve for C. So I'm going to say sine of C over 8 equals sine of A over side A, 6.67. So solving for C in this case, we actually end up with, I'm not going to go through all the steps. If you're curious, maybe watch the previous videos. So I'll multiply both sides by 8 and then take sine inverse. And now that I have C, I can use that the sum of all the angles has to be 180 degrees. And so I end up with B approximately equaling 96.8. to do that, I said b plus 46.2 plus 37 has to be 180. And just to kind of recap here, we had a was 6.67. So this is my final answer. I have the missing side and I have the missing angles. All right. Next up, we are going to use, this will be part B. So we're still going to be finding the missing parts, except now the triangle is going to be A is 5. Let's not worry about units. This one, B is 8, and C is going to be 9. So if we're going to draw this triangle out, we end up with 5, 8, and 9. This is angle A, this is angle C, this is angle B. You can orient this however you want. I'll keep reiterating that, but this is just my generic triangle. So now notice you're given all three sides. That means it's an SSS. So we're going to use cosine of an angle. We're going to use the alternate version of the law of cosines. And I'll just go ahead and use, I'll just go with cosine of C since that's how it's written. No real reason for this. I'm going to end up with a squared plus b squared minus c squared all over 2 times a times b. So you would solve all this out, and you would end up with cosine of c equals 1 over 10. If you reduce the fraction, it's 8 over 80, which means we now have to use cosine inverse. Luckily, with cosine inverse, there's no ambiguity because the alternate option when you do cosine inverse is an angle that is greater than 180 degrees, so that won't fit in a triangle. So if we plug this into the calculator, we should end up with approximately 84.3 degrees. Now we're going to use law of sines, but keep in mind we don't want to use the largest angle. Luckily, since I did C, I already found the largest angle. So that means I could actually solve for either one next, and I won't hit any ambiguity. Since this is the largest angle, we can solve for either A or B. So it doesn't really matter. I'll just go with A. Sine of A over side length A, which was 5, has to equal sine of the angle I just found over side C, which was 9. Solving for A, multiply by 5, take sine inverse. We end up with approximately 33.5 degrees. And then using that the sum is 180, we get that B is approximately 62.2 degrees. So there you go. So we've now covered law of sines and cosines. Keep in mind that in most problems, you're going to have to use sort of a combo of both. Law of cosines followed by law of sines, and then maybe the sum is 180. Law of sines problems, you don't necessarily have to use both, but you can if you want. So just to kind of recap, the law of sines is used for AAS, ASA, and ASS. And the law of sines is that all of these ratios are equal. And then for law of cosines, we use this for SAS and also SSS. And this says that c squared equals a squared plus b squared minus 2 times a times b times the cosine of c. Or we might have to solve for an angle. Cosine of c equals a squared plus b squared minus c squared all over 2ab. And that concludes law of sines and law of cosines. For the next part, we'll see a couple more different types of examples we can solve.